Okay, guys. So, as I said in our last class, right? So we are going to write our own image. We are going to build our own image. So far, whatever we have worked, we worked on the inbuilt images provided by the Docker Hub or Docker registry, right? So here we're going to see in real time in your project in a company, right? You don't have to actually dependent on the images, default images or the inbuilt images being provided. So you have to write your own image based on your requirement, right? Based on your deployment strategy, based on your requirement, based on your application, you have to write your own image. Okay, so to write your own image or to build your own image and create your own image, what you have to do, you have to write this instructions in a file that's called the Dockerfile. And make sure that Dockerfile, whenever you create the Dockerfile, and you have to keep in a context where the context is clean and the required files for the images to build, you need to keep it there. The unnecessary junks, unnecessary stops, you don't have to put it there. Otherwise, it will increase the size of the images unnecessary, right? So let me just log into the Docker server. Okay, so I just connected. Now what we can do here, so if I just do Docker image ls, you can see we have few images available here, right? And if you want to just delete all the images, what you can do here, uh, either you can do image rm and delete one, or else what you can do, if I just want to ls-q, here we can get this image IDs, right? So in our last class, like yesterday's class, I just showed you, right, how we can delete all the exited container or all the defunct the date containers at one time, right? If there are more than 100, more than 10 there, you cannot do one by one, right? So you can together in the group bunch, you can just delete everything, right? So what you can do, you can here also write Docker. So the command is to delete image rm, and here you can just create a subcell, and inside this subcell you can just put the command which provide the image id. So it will be docker image ls-q. So this will provide us the image id, and that will be passed as input to this one. So it will be deleted everything. Now let's hit enter. Good. So everything is deleted, but one thing is says like error response from the daemon. Conflict unable to delete image is being used, right, by a container. By this container is being used. Now let's check which container is running. Docker container ls. So we have this container which we had done the demo yesterday. It's still running 24 hours ago, right? 24 hours ago, it's still running. So let's delete this container first. Okay, delete this container first. Or if you want to forcefully delete that image, you can still do that. So how you have to do, you have to just use rm-f, right? So for safer side, just delete the container rm-f. Again, it's running. So forcefully we have to also delete it, delete the container. Then now we can delete the image. Unable to delete must be forced. The image is being used by another container. Okay, that should be another container, maybe bgbox, I think, Docker set container ls-a. Yes, the bgbox thing. Okay, these are things there. Let's forcefully delete rm-f. So delete it, right? This is the way you have to troubleshoot and you have to work on this. Okay, now leave this part. Leave this part. So what I was
Ajit,
yeah.
one question like so one image will be used by multiple containers, right?
Yes, you can create n
Okay.
number of containers. You can create n number of containers.
Yeah. For example, like we have one image, so that image can be used by 2 or 3 containers.
Not 2 or 3 containers. You can create n number of containers.
Okay, okay.
You can create.
Because like in this case, like there were one image, so it has been used by BC box and that HTTP one more container, right?
No. What you saw, the BGBox was using by other image, BGBox image, and the HTTPD was being used by the HTTPD container, the Apache server container. That's totally different.
Okay, okay. But when you try to delete the HTTP container, so you are not able to connect, right? So it's showing images used by other containers, some error we achieved.
Because that HTTPD container was also running, right? When I deleted the HTTPD image, right? When I deleted the HTTPD image, it threw error because the HTTPD container was still running. It's still there.
Okay, then in the case we need to stop the container and then delete the.
Yeah, then I stopped I deleted the container first and deleted the image, right?
Okay, okay.
After then, when I started deleting the image again, then I found error of BGBox. Then I saw that there are also a container of BGBox. Right?
Okay.
I deleted the BGBox container and then images forcefully, right? So that's what you have to do. Okay, now, yesterday I was showing you to write the Dockerfile, right? So what do you have to do, and this is my context area. So what you can do here, if you see here, we have this PWD, and we have this app, this particular folder. We don't have anything available here. It's clean, right? This is totally clean. We don't have anything here. Now, let's create a Docker file. So how we have to create? Just use Docker file, D uppercase. Okay. Now hit enter. Okay. And while writing the Docker file, let me just show you the Dockerfile thing. This is the Dockerfile reference, right? So you have to follow this reference, and here you can find the command list, right? The command list where you can get it. And remember, when you start the Dockerfile must begin with a from instructions. What happens? You just read this. The instructions is not case sensitive. However, convention is for them to be uppercase, distinguish them from the arguments more easily. That means whenever you write these commands, make sure that you write in the uppercase. What it says is not case sensitive. That means you can write the lowercase as well. You can write the lowercase as well, but to make it distinguish them from the arguments more easily, we can make this in uppercase so that you can distinguish that these are the commands being used in the Docker file. And Docker runs instructions in a Docker file in order. It means in sequentially, in order, one after another, it will run. So a Docker file must begin with a from instruction. So the from instruction is the base image. That's called the base image. Okay. Now let's give an example. Okay, before giving an example, let me just show you how you have to write it first, and with a small example, and then we'll move into the other complicated and the complex examples, and we'll see how it can be done. Okay, now, so my requirement is to just create an image which will create a container to execute a script. Right? Now, what I can do here to execute a script, suppose I just want a small Linux box, Linux utility. Suppose the BZ box will be the best suitable for us, right? So I need the base image. That's we have to write the from BZ box, right? From BZ box. So the base image I'm going to use it BZ box. On top of that, I'm going to add a few more layers. Okay, so let me just show you here. It's very simple things there. I'm going to give you these examples here. Okay, I'm going to show you this example to you. Now, what happens here? From BG box, I'm going to copy a script. I'm going to copy a script. So what is the script name? Test.sh. Where to copy? To var. To var, right? Now what I'm going to do, let's copy. So copy is a command. But in Docker command line, the copy command is cp, right? Docker cp and copy the file to the container. But here in the Docker file, the command is copy. So I'm going to copy this. What I'm going to copy? Suppose I will copy test.sh or something like app.sh to tmp folder, right? And let's make this tmp folder as my working directory. So I'll make it as work_dir/tmp. So this tmp will be my work directory. So what is this working directory? The working directory, whenever you create a container, right? Whenever you go inside container, you used to see, right? Will be landed into the working directory. The first enter will get the working directory. That means when you create the container, the working directory, whatever things are there inside that container, from there everything will be executed, and from there the container will work. The work directory, right? So you'll be thinking, right, where I'll get this kind of commands, from where I can get this kind of commands. So if you just go to the Dockerfile reference, right? If I go to the Dockerfile reference, you'll find there are all commands available here. See what I just used? I used copy, right? See, copy. Then I used what? Work directory. Let's see what is this work directory. See, this work directory, the work directory instruction sets the working directory of any run, cmd, entry point, copy, and add instructions that follow in the Docker file. That means whatever the commands you are going to use, these are the commands: run, cmd, entry point, copy, and add instructions that follow in the Docker file. That means we are going to set that these are commands which will start working from the working directory which we have set up. Now what happened here? I just copied one script to this temp directory of the container, and then from there I'm just giving another instructions, then make this tmp directory as my working directory. And in the next statement, I'm going to write next instructions to execute the command. Going to execute sh, comma, going to run this app.sh. So what happened? When this command will be executed, this command will executed from this tmp folder, tmp directory. And in this tmp directory, we have this app.sh file. We have this app.sh file, right? Now let's save this one. Now let's save this Docker file. Any doubt, guys? So this is just a starting, right? We have to explain, we have to go further and to understand a bit more of all these items. Okay. So far, did you understand, guys, everything, or you have still any doubt?
Yeah, the copy command, right? So we are copying that app.sh from local to that DCBox, correct?
Exactly. Local to the image to the container.
Okay.
Okay. So the BGBox, on the BGBox, so what will happen? How this image will be built? First, it will download this BGBox image, right? And on top of BGBox image, what will happen? It will copy this app.sh to the tmp folder of this container, BGBox image container, and then it will create the working directory, and then it will execute the command, right? Now let's do that. So first, I'm going to copy this app.sh, right? And make sure that this app.sh is also available in your system, right? Now we have this ls. When I did ls-l, I can just find only Docker file I wrote it. Now let's create this app.sh, because that is the file I just need to copy it, right? And I'm going to write something. So what I'll do here, just give it echo. Okay, what it says? I'm just writing an echo statement to print it here. So echo, I am executed from the container. And give me, let me give a few more examples. Suppose I'll give the current working directory. I'll give it as so the command will be executed as PWA. So guys who have a little bit ideas on the scripting, self-scripting can understand. If you don't understand, let me just explain you. Okay, let me just finish it off and okay. So what happened here? I in this shell script, I just wrote few echo statement to print. What I said, it's just printing small statement here. I'm executed from a container, then current working directory. Inside this, what happened? I just executed a command called pwd here, and here is the back quoted. Inside the back quoted, if you are going to execute within the double quote, then you have to execute like this. Put it to give the command and here the date. Okay. Similarly, what I'm going to do here, let's save this file. Let's save this file and make sure like whenever you create any shell script, make sure that you make it as executables, right? You have to give full permissions to ch mode. Suppose I'll give +x app.sh. Now we get this. See, we got this executable permissions. Now, what I need, I got my Dockerfile ready in this context area, in this directory. We have two files. One is the Dockerfile, and another is the app.sh, which is required to be copied to the image or the container. Right now, we need to build to create the image. Okay, we need this to build and create the image. Right now, how we'll do that? The command will be Docker. You can either use image build or directly build. Okay, so let's do image help. We'll find it out the details. See what it says: build an image from a Docker file. Right now, what you can do here: Docker image, the management command. Then the command subcommand you have to put it as build, right? And you have to put it. You have to give a tag -t and give a name to the image. So you have to give a name to the image, right? I can give like my just my image, something I gave a name to it, my image colon. I give a tag 1.0, suppose dot. If I don't give 1.0, it will create the latest image, my image. Okay, so the image name will be my image 1.0 dot. Okay, now hit enter. So see the step one, what it does, it just executing this from BGBox. So first pulling this BGBox and just executing it. After that, the second step, what it did, it just see the step 2, copy this particular to TMP directory, to the TMP directory. And then step 3, selecting this, making it working directory TMP, and then it's just executing this command. So now if I just do Docker image ls, see, we have this my image is created. We have our my image tag 1.0 is created. Okay, now if I want to create a container out of that, right? I will do that. Use Docker container run, right? And use the image name. What is the image name? My image 1.0. Hit enter. See what happens? It created the container and executed whatever the instructions was provided in the image. I am executed from the container, and the current working directory is TMP, and today's date is given as this one, right? So if I just check whether the container is created or not, if I just do Docker container ls. So it is exited, right? So see, we have this my image, this particular container, and it executed the command, this particular script. So this is a very simple to understand, to demonstrate how you can create your own image and execute it. Okay, this is a very small example. Now let's go beyond that and see. So in our last class, what we had done, if you remember, I had created one Apache server. And that Apache server, I had used the image HTTPD, right? That image, what I did, I created that image, and then what happened? I copied manually to the running container in order to execute the, or in order to deployment the applications, or in order to copy the index.html file, right? The same thing, actually, that is the demonstrations I was showing you how we can do that, manually copy some stuff to a container. But actually, the requirement comes actually how you have to work on this. If you're working in your project, right? A requirement, suppose a real-time requirement comes, you have to create one Apache server. Suppose your development guys have worked some PHP development. Some PHP development has been done, or some HTML website, some e-commerce site or something you guys might have developed. And you need that to be deployed into one Apache server container, Apache container, right? HTTPD container. So the requirement comes to you, right? You have to write the Apache server container. So how you have to write your, so we cannot directly create a container from HTTPD server, getting it from the registry. What you can do, you can simply, what do? You can simply get the image file, right? And then you have to add the layers of the instructions as per your requirement. So how you will do that? Let me just create another folder, free complete folder. Suppose I'll just make like another context area, right? Where I'm, as per requirement, I'm going to create it. Now let's do that like web app, something like this. Okay. Let me copy this index file to this web, and this is the file I just want to. If I go to web app folder, so we have this index.html file. I just put it there. Now what happened? What I want, I need to write one Docker file. I want to write a Docker file, right? So let's write it, Docker file, enter. So here, what should be the base image? What should be the base image here?
HTTPD.
Exactly. So it should be HTTPD. So you have to write from HTTPD, right? And here, if I do only HTTPD, then it may impact your work, right? So you have to make sure that which particular version do you need for your server, right? For which particular versions do you need for the server? For that, you can go to the, where you can go to the Docker Hub,
Docker
and
Hub.
there you can find where it is. Okay, there you can find which particular tag do you need for your Apache server. So is it clear, guys? Now, for the time being, let it be HTTPD, only the latest versions. Okay. Now, for better understanding, let me give one versions for you, right? So suppose I need this particular versions of HTTPD. I'll just search for which tag you have available. Suppose I need 2.4. Okay, I need 2.4. Let's go here, colon 2.4. From this image, particular image, what I need to add. First, what I need to copy the index file, right? I need to copy the index file. So let's use copy, right? Index.html, okay, to user local and to the folder where Apache shoe, then htdocs. This is the folder where I'll just copy this index.html from locally to this container directly, Now just hit enter. What I do next, I just want to make this particular directory as my working directory. Any directory, if you want to make it, By default, the working directory is this one. So I don't need to change any working directory here. My simple work is to copy this particular things to htdocs. That's very simple, right? Very simple. Let's do that here. htdocs. Save it. Done it. Now, what I need, I just wrote small, very small for your understanding, and I will just make it big, right? Don't worry. Very small from, and I just copied this one to this htdocs folder. Now let's build the image. So what is the command? Docker image build -t. I can give web app version 1.0, right? And dot. So why dot, guys? Dot means the current directory. In this current directory, we have this Dockerfile available. We don't have to specify the Dockerfile name here. You have to just specify dot. That means it will just execute get the Dockerfile and get executed, right? Now let's hit enter. See, first it is downloading the HTTPD image, HTTPD 2.4 image, and top of that, it just copy this one. Now if I just do Docker image ls, see, we have this web app 1.0 version available. Now what I can do here, I will create a container and let's see how it is working. Okay, what I'll do here, I'll just use let's refresh this one. Okay, anyway, this container is no more there, right? That's why it just cannot be erased. So what I can do here, if I just create another container, if I just go ahead and create another container, suppose Docker container run, okay, and give a name to it. Suppose I'll give name my web app, something like this, right? And give the image name. So image name is web app colon 1.0. Okay, so as it is a web applications and is a Apache server, web server, I need this to be accessed through the web browser, and I need the port to be, so Apache server default port is 80, right? So I need this port to be published or forwarded. So to do that, I can use publish p. Then suppose I'll forward to 8080:80. So this 80 is our container port, and this 8080 is our host port, right? Now let's hit enter. So here, one thing you can notice, guys, I did not specify -d option, detached mode. So what happened here, when I created this container, what happened, it just attached to the terminal, right? We can see the logs here itself. Now, even though it is created and attached, we would have the container created, right? Now, if I go ahead and just use the, see, I refresh this, and with this container and port number 8080, we got our application running. Okay. Now we got our one image version 1.0. Suppose there another requirement may come where you may need to modify something into your application. Need to modify something into your applications. For that, what happens? Suppose either your applications require something, and you have to suppose put one image here. Okay, image into the index.html file, right? Index.html file. So what we can do here? Let me just modify the index.html file first, and then we'll talk about it.
I have a question actually.
Yeah.
While creating an image itself, whether we can be able to give that port number, or after creating a container, we have to give the port number.
See, this is where you can just publish the port. Okay, yeah. 8080. There you can directly publish a port also in the Docker file, but that's not the way you have to do that. Okay, because see, if you make one port, why that is because, see, your container, same image, you may create multiple containers. Suppose you can create multiple containers. Okay, let me just do that example, then you can understand. Now I just exited this container, right? Okay.
Yes.
Let me give you an example here. Let's go to the Dockerfile reference. And if I just go here, we have this expose command is there. If you see just expose command, what it does, the expose port, right? See here, exposing the port. Expose instructions from informs Docker that container listens on the specified network ports at runtime. Can specify whether the port. Okay, so why by default actually this expose of HTTPD is 80 because HTTPD run on 80. But for your case, you said like whether we can give the 8080 at the run means and in the Dockerfile or not. It's actually
Yes.
not suitable and it's actually not advisable to give it because why? See, let me give you an example. First Docker container RM. First, let me delete this one. Okay. If I just execute this container with 8080, okay. Suppose let me give run hyphen D in detached mode hyphen D detached mode. And if you are saying that instead of giving it here this 8080 port, why should not give in this image?
Yeah, that's what.
The build. If
Yeah.
I give this 8080 image, suppose I need tomorrow, I need another 2 containers. What will happen? Same port you cannot be used, right? Same port cannot be used to create another container. It will throw error because applications can run on one single port only, right? The server can run on single port only. If I just use the same image again and again, it will not allow us to create because it will throw error because the same port is already being used. But if you don't use that one and specify at runtime, what is the benefit? If I just need another container of the same image, right? I can suppose give 82. Okay, the name is same name, so I need to just change it to above 1. I create another container here. Okay, now suppose I need same image to be another container to be created 83. Okay, let's change the name. See, I got 3 containers of the same image, but it's running on different port. Okay, if you think I can use the same port again, let's see if I use the same port again, what it will say. What is it? Error response from demo, driver failed connectivity on a endpoint web of 3. Bind for this failed port is already allocated. That's why if I just give 8080 and the image itself, we cannot create a multiple container. It will say port is already being used or allocated. Okay, so here, when I gave runtime, at runtime, I created multiple containers. At runtime, I created multiple containers, right? Let's check Docker container. Let's see, we have this web app 1, web app 2. These 3 containers are running, right? So if I just access these 3 containers with the different ports, 82, 83, 83, right? Before accessing, make sure that 82, 82, and 83, 83 are whitelisted on the Docker server. Okay, let me log into the Imagine console. There I have to just change the, I have to provide the, I have to whitelist. Okay, now what I can do, I can quickly go to the instance. I'll quickly go to the instance here. Okay, I'll quickly go to the instance. Let's Just a second, it takes some time to get loaded. Okay, select this one. Let's go to the security. And here you can see I have just whitelisted only 8080 and 8282, but 8383 port is not whitelisted, right? So if I access this Docker, this server and 8080 port, we have one container running, right? And sorry. One server is one container is running. Let's go ahead here and put 8282. Another container is running, right? Let's go ahead and create another one, 8383. So 8383 is not running. See, Docker 8080 is running, 8282 is running, okay? But here, this one is not running. Why? It's because this 8383 port is not whitelisted or not firewalled, right? Firewall not access is not provided. So what I can do in this one, I can just provide 8383. I have to whitelist here in inbound, right? Let's go there and go to the security. And this security, I have to add the port, go to the edit inbound rules. And there I have to add new rule, custom TCP, provide 8383, make it public. Okay, now save the rules. Now I saved the rules. If I go here and refresh, see, now 8383 also came. So we have 8080, 8282, 83. 3 containers are running. 3 containers are currently running. Okay, in one image, I created 3 containers. If I give a same port in the image itself, can I create multiple containers?
No.
No, right? That's the result we can specify at the runtime. Okay. Now, so Jaishlin was asking like the same image can be used for multiple containers. Yes, as I told, we can create n number of containers from the same image. If it is a web application and you want to connect from the port, then make sure that you change different port while creating the container. As I created it, same port cannot be used. Another way. Now I have one image, right? I have the image, right? Let's do that. This folder, I have the Docker file, and suppose I want to little modify. The developer has modified the code. The developer has suppose modify this particular code, right? And this code, suppose developer has added one index, suppose one image to this file, okay, to this file. Now let's I forgot the syntax adding
IMG source, IMG sh.
IMG and then source something.
Source.
Yeah. So yes. So let's copy this particular thing. Okay. Okay. So I need this particular JP, any image, right? I need suppose okay. I need this image. Suppose I'll download one image here. Let's download any one Docker image. Okay, so let's modify this. I'll just add it docker.png. Okay. Now added one image here. So what I can do here, so Docker image I added. I need this particular file to be copied, right? So what I need then, I have to modify the Docker file, right? Vi Dockerfile, copy docker.png file to this particular directory, right? To this particular directory. Let's then what I can do here, let's save this file. And in this context area, there should be docker.png file. Now I have downloaded the docker.png in my local desktop. Now let's copy that file to the Docker server. Okay. So how I'll do that. So I have this docker.png file, right? Now what I can do here, I need to copy. So using scp hyphen I just use the certificate file, okay, to copy. And the file name is, what is that? Docker.png, right? And I need to copy to ec2 hyphen user docker.png home, or you can just give colon this one. So what will happen here? I'm just going to copy by using scp command, copy this particular Docker PNG file from my desktop, from my laptop to this Docker server. Okay, to this Docker server. So what is the folder name? I can give as home ec2 hyphen user, and it was given in the web app. Okay, hit enter. So it is permission denied. Let's put into only home directory. Okay, the file is copied to the home. Why it is denied to copy this? Because this folder actually has only permissions of root user. So as I'm using the normal user, I could not copy. That's why permission denied. Now I tend to put it to the ec2 user. So the file has now been copied to ec2 user, right? So if I go back here into this ec2 folder, right? If I just do ls hyphen here, see this docker.png file has come here, right? Now let's copy this using sudo copy this docker.png to web app folder. cd web app folder. Let's check it. See, docker.png here is now. Now what happened here? We have the required files to build our Dockerfile now. Let's see first the images. What we have, the images. We have this web app 1.0, right? Now what I just want to do, I create another, because we just modified, right? Added new instructions to the Dockerfile. I just want to rebuild the Dockerfile to create a new image, right? To create a new image. So what I can just use Docker image build, okay? Docker image build, give the tag hyphen t web app 1.2. 1.0 is already exists. I created another image 1.2. This is how you are going to release a new versions of the applications into your container, right? You have to create a new image. Now I created a new image 1.2. So it just copied this Docker PNG file to this one, and also the copy index.html to this. Everything's ready now. If I just do Docker image ls here, we have this web app 1.2 tag. right? We have already 3 containers running. Let me stop 2 containers, right? Docker container. So we have this 3 containers running. Let me just delete these 2 containers, 82 and 83 containers. Okay, or let me delete because I just want to use the same 83 port. Suppose I want to use this 83 port. Let me delete this container. Okay, Docker container rm-f. As the container is running forcefully, I just deleted it. Okay, I deleted the container. Now I want my applications to be deployed with new applications to be deployed to the container. So what I have to use? I have to use Docker container run, right? -d -name, give web app one, something like this, and give the port 83 colon 80 is the container port, and give the image name. Image name is web app colon 1.2, right? Let's hit enter. Our container is created now. Okay, now if I go and refresh the 83 port, see, my application has now changed. New deployment. This is the new applications now, and the other application others are still using the old image. Are using still the old image. Now is it very clear, guys, how you have to do this? Any doubts so far, guys?
No.
No.
Cool. So this is how, guys, you have to create multi. Whatever I just told you, right? Everything is the real time. In the real time, how you have to write the images, and if there is any changes done by the development team, you need to rebuild your Dockerfile. You need to rebuild and create a new image. New version of the image will be created, and the deployment will happen from the newer versions of the image. The deployment will happen from the newer versions of the image. Just a second, guys. I'll be back. 1 minute. Okay, guys. So this is how you have to just work on the images. Now, let me just give you some examples and different. Okay. Now, because there are many other commands, right? I cannot go each and everything. So for you, task is to go through this commands and see where the usage of these commands, where to use add, where to use copy, what is this environment command, volumes, user, working directory, we already have discussed, right? Argument and entry point and CMT. These are the few things which I am going to show you now. I'm going to explain, and then you are going to work and do practice. Okay. So what is the
Like for practice purpose, so we can use this, we can edit and we can use the same image, or we need to give a different version only.
sorry, I couldn't get you. Can you?
So actually, for our practicing purpose, so initially you have created 1.0 and you have added image and you have built one more image called 2.0. In
One
the
point.
same 1.0 itself, can we edit and build it again?
Then that is the no point of creating this and see if you need something. Suppose you need to roll back, you need to get the previous version. Then how will get it?
Okay, just for practicing purpose, I asked actually.
No, you
So,
can never do that because even though you do practice, create new image, new version. That is the best practice.
okay,
Always
okay.
create new tag. Okay, that is what, because if you don't do, if you do practice of deleting the previous version, then that practice will make you, then in the real time, if you do same thing, then it will impact your work, right? So never do.
Yeah, okay.
Yeah. So always do.
And one more thing is like in Jenkins, so we used SEM, right? Poll SEM and source code continuously it will poll like that. So here, so we need to once we have the new code and something like that, so we manually need to build it.
Yes, we need to manually build it. And the same thing, see, manually, so only one command you have to use to build it, right? It's not manually. Even though in Jenkins, we can integrate Docker in Jenkins to build it. So Jenkins also will build it for you. You don't have to again manually build it. So here what happens, I showed you to manually execute the command, execute this Docker build command to manually build it, right? Sometimes what happens, not sometimes, and in your company, when you do automations, right, you can integrate the Docker with Jenkins so that Jenkins will automatically pull HTML. GitHub hook will trigger that, and automatically the Docker image will be created for you. Then you have to create container, do the deployment. Okay, that will see.
Okay.
That is the project what we have to do it after the completions of Docker, and we'll do this project in Jenkins. Okay, don't worry.
Okay.
Yeah. So what is that? So we got it. Now let me just explain few things to cover it. Okay. There are few useful commands, Dockerfile commands, and which I believe is useful for you. The copy versus add, right? We use the copy command, but we have not used the add command. When to use copy and when to use add. If you just see this here, we have the add command also, right? Add, see, add commands. When to use these add commands? Let's see the differences. You may get questions on this, okay? So what is the difference? Copy and add are both Dockerfile instructions that serve the similar purpose. They let you copy files from a specific location into the Docker image. So from a specific image to the specific locations into the Docker image. Copy text in a source and destination. It only lets you copy in a local file or a directory from a host, or the host building the Docker image into the Docker image itself. That means using copy, you can locally copy from the path, from the context, or from a specific location locally to the container or to the image. But add, what happens? See, this is what we used, right? We already used this command, copy, index file, all this. But add lets you do that also, but it also supports two other sources. Add can do copy locally. Also, it can copy from a server. Suppose you have an image file or you have a file in a different server. If you want to copy from that server to your image, then you can use add command, not copy command. Copy only can be copied from locally to the destination server, to the destination image. But add can give you from different source machine, different source server to the container folder or to the image. Similarly, if you want to copy a zip file, what it do? You can use add this gz file. What it do? it will add this file, and while adding, it will extract also. This is a compressed file, tar.tar file. When I copy using add a command, it will untar this on this folder. The archive file also can be downloaded and extracted in run command. So you, instead of using this, you go with run command. So what this run command does, let me explain you the run command. The run. So the run instructions will execute any command in a new layer on top of current image. If you want to execute any cell command, if you want to execute any installations, if you want to do any installations, you can go with run command. Okay, you can go with run command. Let me show you this run command example. I have in my GitHub repository, you can just go there also. In my GitHub repository, I have few things. I had recently created one YouTube video for that, and I have kept everything in this GitHub repository as public. So you can go with okay. So in this Dockerfile DevOps tool, right? Dockerfile DevOps tool, I have created 3 Docker files for different different tools. For Ansible, for Git, for Terraform, I have created. Let me show you for the Dockerfile Git. Here I have written, see, small. I have written small Docker file where being run command used. So the run command used to install some Git, see, apt-get install Git, install Vim editor. You can use run command to install something. Same thing is being given it here, right? So the run command instruction is given to install or execute some commands. Okay, now, okay, let me explain further here. So you can, using run command, you can download this particular file, and using run command again, you can use tar command to extract this file on this particular folder, right? So which is good. Here in this case, you have to execute 2 commands. But if you use add, what it will do, it will just get this file and extract into this folder. That's all. So that is the benefit of using copy versus add. That is the differentiations. Okay, then this is the benefit of using add command. Now let's see other few more commands. Entry point and CMD. This is a very good good command, and you'll get lots of maybe questions on this. What is the most important and differences between entry point and CMD? So the entry point and CMD, we saw the example of the CMD, right? To execute the shell script, right? I just wrote a BGBox image, and there I had written to execute, right? CMD, SH, and shell script, right? Here, why then we have to go with entry point? See, entry point to CMD when building executable Docker image, and you need to command always to be executed. Prefer entry point, so remember this line. You should go with the entry point when you want the Docker image and you need the command to be always executed. Then you should go with entry point. Additionally, use CMD if you need to provide extra default arguments that could be overwritten from command line. Remember, if you are using entry point, then CMD command must be used. If you're not using entry point, then you may or may not use CMD. That's not mandatory. But if you're using entry point, then CMD is must, right? So how you used CMD? You can use CMD echo here. And if you do that, create one CMD echo here. If I just create image name and execute in the bin bash, then it will just execute it. So when the container create the extra command in the runtime, it will be overwritten. This one. Now, the difference is entry point command and parameter are not ignored when Docker containers run with command line parameter. So here we use CMD echo hello Docker, right? Let me give you an example here. Let me give you an example here. Let me create one Docker file. And here, base image suppose from BGBox, CMD. Okay, CMD. What is this? I'll just write the command called echo hello Docker. Save it. Let's build the image. Docker image build -t demo colon 1.0. Right? We got demo 1.0 image. We got demo 1.0 image. Let's create container. Let's see what is happening. Docker run -it demo 1.0, right? Demo 1.0. Hit enter. So what it says hello Docker. This particular image gives us hello Docker. This is the only things which was given in the instructions of this image, right? Hello Docker. So if I just pass another command here, right? I'll just give us suppose Ranjit. Sorry, it will not work. Suppose I give, I should give an executable here. Suppose I'll give bin bash. Well, run created, unable to start container process bin bash. That's no such file or directory unknown. Okay, so it's not running by providing this -it options and bin bash. Okay, if I just do okay, it's not working. But the same things, if I use the entry point, right? Now let's go to the entry point. In this same Docker file, instead of adding CMD, let me just use entry point here, entry point. Okay, now what I have to do, let's use this complete copy paste there. It saves some time. But I used one command bin echo hello DevOps, right? Let's save this one. Let's build to a new image 1.1. Okay, same image you can 1.0 also you can do, not a problem. Okay, it will overwritten, but better to give a new tag. So we got a new image 1.1. Now let's build with this 1.1. so what it gives, hello DevOps. Now if I just want to, let's modify this image here again. What I do here, I echo here CMD let's build 1.2. Done. Let's execute the command 1.2. So what it gives, only Docker here, only Docker. What will happen here? What happened here? The entry point. Okay, so entry point, suppose let's give DevOps. Save it. Let's rebuild. So what it is giving, guys? It gives DevOps and Docker. It both gives DevOps and Docker. So if I just open the Docker file, what happens here? It first printing DevOps and then giving Docker, right? So what will happen here? Let's go back and use our two image. 2 is only giving Docker, right? So if I use here DevOps, see, it gives DevOps. If I use anything here, it gives. So what is this actually? Why it is behaving like this? What happened here? This entry point, if you are providing this entry point, if you don't provide anything here, that's okay. If you don't provide anything here, with this entry point, with this command, we are executing this particular Docker, giving echo Docker. If you want to override this, if you want to override this in the runtime, then you have to use this entry point. You have to use this entry point. Instead of Docker, if you want to override DevOps, it gives us DevOps. If we override Ranjit, then it gives us Ranjit, right? Now let's give you another example. Let's show you another examples. I'll just show you, then you have to do the practice, okay? Okay, same examples, but let me just edit it. Instead of this, I can just give you ping. And here, suppose I'll give you google.com. So what will do, this command from VGBox, it will ping this google.com server. It will ping this google.com server, right? Now let's hit enter. Now build another image, right? Build another image, 0.4 suppose. Oh, sorry. It's not, I need to use build, right? Build 1.4. Done. 1.4. See what happened? Our container is pinging now, right? Our container is pinging google.com. Container is pinging google.com. Let me come out here. Now, suppose you want to ping something else. By default, it is pinging google.com because we have pressed, we have given the command google.com. If you want to change it to something else, suppose I want to ping ranjitswamy.com server. ranjitswamy.com server, right? What will happen? See, it is pinging ranjitswamy.com. Anything you want to override the command during the runtime, then you have to go with this entry point. That is what I just want to show you. Now, the entry point specifies the command that will always be executed when the container starts. The entry, and CMD specifies the argument that will be fed to the entry point. So if you want to fed to the entry point, then you have to go with the entry point CMD combination. If you want to make an image dedicated to a specific command, you will use entry point. Okay, that is what being used. Now, another good example, another good differentiations is between the ARG versus environment. ARG means argument. How will create argument in the Docker image, in the container, right? So if I go to this Dockerfile, you'll find this arg and env environment, this environment variable. The env instruction sets the environment variable in the Dockerfile, and arg is the provide the argument. Arg is the provide different variables that user can pass build time. The build time. Okay, let's see the difference here. There may come a time where you may want to add an environment variable to your Docker image, but you will want this value to be different depending on where you build your images, but you don't want to edit your Docker file. Suppose whatever you have given to in a Docker file, you don't want to edit it. Sometimes if you have created the environment variable and don't want to edit it in the Docker file, but during the runtime you want to change it. So you can do that by using the, suppose here I have written small argument, your application environment is productions, and created one environment variable, and here I have given the argument as your app environment. This is the argument. Okay, your app underscore environment, and here your app underscore environment is given as the productions. Now, if you run this during the runtime, it first gives us productions. If you want to change this productions and run into a staging environment, then during the build time, without changing the code, during the build time, you can specify with this particular hyphen build hyphen arc, and you have to provide the argument as staging. Then it will change the image without changing the Docker file. Without changing the Docker file. Let me just copy this part and just ping you and keep it handy and do practice. This is a task for you. I'll just move on to the different next topic. So this is a task for you. I just ping you this related to particular build environment and argument, and you do practice. Okay, today.
So this is similar to that entry point, right?
Exactly. It's that has different roles, but similar to this entry point. That's totally different. Okay.
Okay.
Yeah. Now, that is another very important thing. So I'm going to discuss with you is the Docker ignore. So what is this Docker ignore, Dosh? This Docker ignore actually, before the Docker CLI sends the context to the Docker daemon, it looks for a file named Docker ignore. Okay. So whatever we have kept in this context file, PW, this is the context. Suppose let me go to the web app. What is this? Oh, it's in the note. CD home feature. Not user, C2 user. C2 hyphen user web app. What happened? Now, if I just go here, we have this in context file, we have lots of files there. When you should go with Docker ignore, and why Docker ignore dot in Unix or Linux, dot is treated as a hidden file, If you don't want any context, any file or anything in the context to be copied during the build time into the image, you can specify those things in the docker.ignore file. Okay, so what kind of file you don't want to build? The sensitive informations, the credentials, the password, those things you don't want to copy to the image file. Okay, so that you can, or anything which you don't want some extra file generated during the build you don't want to copy, then you can insert in the Docker ignore. Okay, suppose how you'll create it in this context file, you will create vi suppose dot Docker ignore. This is how you have to write dot Docker ignore. Hit enter. Suppose I don't want start.cnf or db.config, something. These two files, or the files which are ending with .cnf, and the file name is db.cnf, db.conf, like config, sorry, db.config. I don't want this file to be copied. I don't want this file to be copied, right? So what you can do, you can just add it, and while during the build, these particular two files will not be copied. That is the usage of the Docker ignore. That is what is equal. If this file exists, the CLI modifies the context to exclude files and directories that match patterns in it. This helps to avoid unnecessarily sending large and sensitive files and directories to the daemon and potentially adding them to image using add or copy. This is what you have to use it. Okay, guys. So that's all for today's class. So now next class we'll have the Docker Compose discussion, how we can create multi containers and how we can manage them. Also, we'll do a project in our next class and next Saturday. Then we'll finish this off next Saturday. Okay.